homework. Yes, let's talk about the homework. First of all, I have homework to give back so that people who already turned it in. And I made a record of each problem separately for myself of which ones you did, which ones you got correct, what you did wrong. And during the computer part, I can circulate and look at it one-on-one with you and try to get you to understand what you did possibly wrong. And great. Tony is not here yet. Annie. Sen is not here yet.
Yeah,
Jeremy has a unique signature. Audrey.
Over to the student so I can see.
That's my sign machine.
Sitting there.
Okay. So let's do the problems in order that I suggested them. The proof that, or the derivation. Yes? Sure. Okay, first of all, cosine of alpha plus beta. Any questions?
Where's that question?
That was, I gave you two circles, one with an angle alpha there and an angle minus beta here. So beta is positive, minus beta is negative, and said find the distance between those 2 points. And then likewise, here's a circle, and here is the angle alpha plus beta, which is the same as this. And
that wasn't one of.
That was one of the problems.
That looks like.
Okay, so if you were confused, so the first thing to do was write down the distance between these 2 points and the distance between these 2 points. And I think that's as far as you got. But then you have to set them equal, square both sides to get rid of the square roots, just multiply out all those squares, watch sine squared and cosine squared add up to 1 a bunch of times, cancel things from both sides, cancel, I think, a -2 from both sides, and then the result at the end was cosine of alpha plus beta is equal to cosine minus sine alpha beta.
I totally forgot. I keep forgetting about this.
You got part what? Yes.
The farthest I was able to get to was cosine alpha plus beta equals cosine 2 beta minus sine alpha squared plus sine alpha beta.
Why don't I look at it with you during your computer time, actually, at your
I was
paper?
fully understand the simplification.
All the algebra that's needed. Yeah, well, that's
How to
you know.
apply the identity.
Pardon me?
I don't understand how to apply the identity to cancel out the sine and cosines.
Okay, well, sine squared of anything plus cosine squared of anything is equal to 1, as long as those two things are the same, whatever they are. So in one case, on one side of the equation, you had an alpha and also a beta and a beta. On the other side of the equation, you had an alpha plus beta and an alpha plus beta, and then they added up. Okay? If I remember right. Okay, so I should look at your algebra with you, and if you already turned it in, I'll find it afterwards, and we can pull it out. Okay, other homework being turned in? Your name's on it?
They're in the, this color.
Julian, and here, write your name on there, and give it back to me. And I find it very strange when I get a college student who comes in and writes only a first name on homework, as if I'm supposed to, well, here I know there's only one Hung Sen. However, when I have a Peter in my class, and there's more than one of them, it's really hard to know who is turning in homework and not. So you should learn to write down your name, which means including your last name. Okay. And then a few people just came in. I have payment receipts to give out to some people for the leave. And give those to your parents. Okay. And to some homeworks to give back that I already graded. Tony. And I actually graded it, yes. And I kept a record of each of the two problems, what you did and what you didn't do. And during the computer part, you can call me over and we can go over the things that you didn't get right. And that's the reason one-on-one discussion is actually best. Okay, so the next problem was, and I just put away the piece of paper, the identity for getting cosine squared. There were, I think, 2 or 3 people who already turned it in who started from something and went back to the same thing. You don't start with what you're trying to prove. You start with a known fact, keep modifying it with legal algebra until you get to the thing you're trying to prove. You don't start with what you prove because you don't know it yet. Okay? You start with things you know and get to something you don't know. And so the one I did in class, and I'm going to repeat it, was cosine of 2 times an angle. By the way, theta is drawn. You start here, you go around, and then you come across. Okay? Don't do it this way. Okay? I saw too many of those which look like 2's. Okay? And you're going to get yourself confused. Yes?
Can you just draw a circle?
Yes, you can also draw a circle and put a horizontal line through it. This is like printing and this is like script in English. Okay? What did you want to say?
Nothing.
Okay. This looks too much like a 2, and I saw a bunch of them where that evolved into that. Okay? So, that's a theta. A phi is that or that. Okay? And I see my college students writing something like that, and I can't tell if it's a theta or a phi. Okay? So, work on your handwriting now. It's annoying that you got to pay attention to handwriting, but otherwise you're going to
How
get
do you
yourself
rank
messed
these
up.
chairs?
Pardon me?
These chairs.
No idea. Is there another chair around to roll over? There's one. Is that better height? You can trade. Okay. All right. So we have a couple different versions of the identity here, and one of them was 1 minus 2 sine squared theta. I think that's the one I started with in class. And so I wanted to get a formula for sine squared. You start with a known formula, and the last line ought to be a formula for sine squared theta equals something. Okay? You don't start with this and try to show why it's true. Okay? You don't start with that. You start with a known thing and start modifying it until you get this. Okay, so what I want to do is add 2 sine squared theta to both sides. Then I want to subtract cosine of 2 theta. From both sides. Then I want to divide through by 2. And I get 1 minus cosine of 2 theta over 2. Okay?
Then you find the square root.
Don't need a square root. The question was find an identity for sine squared. Find a formula for the square
No.
of sine. Well, the one on homework was a formula for cosine squared.
Oh, yeah, so the one was cosine.
Okay? So you have to start with the cosine of 2 theta
No, it
equals
wasn't,
1
it wasn't
plus.
squared. It wasn't squared.
Pardon me?
All of
There was
them
another
square.
one with the square root, but that,
No, both of them are square roots.
there were identities with square roots, but this is not the one. I'm sorry. Let me let you speak
Well,
instead of me.
question harder.
Here you go.
See both the meteor of them.
That's not the one I'm talking about. I'm talking about this one. Okay? That's fine. These two are also, they're different problems. Okay? And so you have to start with the identity, that identity, okay? And simply solve for this. So you don't start with the correct answer and work back to that, because that's going in the wrong direction. A proof starts with something you know and gets something new. Okay? Because that's how you write down proofs. And I see I left a parenthesis. Okay, so hopefully a bunch of you managed to do that. Okay, the next one. Which one do you want to question? Square root one? Or okay, then let's go do a little bit at the square root ones. So I will do one of them, and it asks you to do both of them. So I'll do one of the two of them now. If anybody still hasn't done it, you can still try to do it. Yes? Okay, I'm still on this one first, and I'll get to that. Okay? Okay, so let's do the cosine one, and you can do the sine one. So we're trying to get cosine of alpha over 2 equals the square root plus or minus the square root of 1 plus cosine alpha over 2. And then there was a statement of when you use the plus sign and when you use the minus sign, depending on which quadrant alpha over 2 is. Okay? So, it's suggested, start with the cosine identity. And so for the cosine one here, you start with the cosine of 2 beta equals 2 cosine squared beta minus 1. And then it said let, and it's not bad if you write the word let. That's good. In writing a proof, you should write down with English words as well. Let alpha equal 2 beta, so that we can get an alpha there. But then what are we going to write here? Beta will be 1/2 of alpha, or alpha divided by 2. And then we rewrite the identity using that fact. And it tells us cosine of alpha is twice the cosine squared of alpha over 2 minus 1. Now, we've got a cosine alpha of 2 we're trying to get, so we simply have to solve for that. I add 1 to both sides of the equation. 1 plus cosine alpha equals 2 cosine squared of alpha over 2. Question? Okay. And then I divide through by 2. Mark. Cosine squared alpha over 2 is equal to 1 plus cosine alpha all over 2, which is beginning to look like that. And now all you have to do is take the square root of both sides. However, there's a danger. When you take a number and take the square root, if the number you started with was negative, then you don't get back to where you were. If you start with minus 2, square it and take the square root, you get plus 2, not minus 2. So in order to actually do this, you need to know if this number is positive or negative. Okay? And if it's positive, you use the plus sign. If it's negative, you use the minus sign. And so from this goes to that if or with the plus sign if cosine of alpha over 2 is positive. The minus sign if cosine of alpha over 2 is negative. And so now we have to think about, when is alpha over 2, its cosine, positive or negative? So let's draw the cosine function. Start there, come around, and now because it's alpha over 2, we got to go further, I think. Maybe we only have to go half as far. I can't remember. Okay? So this is theta, and the graph is the graph of the cosine of theta. So now let's look at alpha. Here's a plot of alpha over 2, first quadrant, second quadrant, third quadrant, fourth quadrant. If alpha over 2 is in the first quadrant, then is the cosine positive or negative in this quadrant?
Positive.
So alpha over 2 in the first quadrant, we get a plus sign. Alpha over 2 in the second quadrant is the cosine, which measures sideways, the x-coordinate.
Negative.
Is that positive or negative here?
Negative.
Negative. So this is alpha over 2 in quadrant 2. Over here is alpha over 2. Is its cosine positive or negative? Cosine measures the x-coordinate.
Negative.
Negative. It's on the negative side. So Roman numeral 3 goes there. And over here is cosine of alpha over 2 positive or negative?
Positive.
Positive. So 4 goes there. So I didn't even need that graph. Okay? And is that what it said? For the cosine 1 or 4 gives the plus sign here, and 2 and 3 give the minus sign. Okay? And so you should look at the sign one again and make sure you understand where the plus or minus comes in. Okay? Any questions on that?
I thought you said you were going to use just regular English. Right?
Pardon me?
I thought you said that it's in the Greek alphabet, Greek Roman alphabet.
Oh,
Yes.
I'm not used to doing that.
Greek alphabet.
I was going to say it was Greek.
Greek alphabet.
You should get used to it.
Otherwise, you forget that you're using angles.
Yeah, that's true. Okay. Okay, that brings us to the fourth one, the product to sum formula. And you had trouble, right? Or something. Let's see what it was. So it said, start with one identity and get the other one. There are 4 of these, and each one follows from one other. So start with 2 sine alpha sine beta equals cosine of alpha minus beta minus cosine of alpha plus beta. Rachel, what did you try to do? Do you need your paper back? Or you still have it? You still have it. We are trying to get to, let me write down what we're trying to get to down here. Cosine gamma minus cosine delta equals minus 2 sine of gamma plus delta over 2 sine of gamma minus delta. All right, so Rachel, what did you try?
I think easy.
You don't remember?
One is only like.
You want to see, did you turn it in already or not? No. Okay, look at this formula and look at this formula. Here we have the difference between 2 cosines. Here we have the product of 2 sines. Up there, here we have the difference of 2 cosines. and here we have a product of two signs, right? So somehow this side has to become that side, and this side has to become that side, or vice versa. Okay, because we're starting from the known one and trying to derive this one. So in order to go from that to that, we need to define gamma and delta, or define alpha and beta. I think that defining the gamma and the delta is easy. So gamma will be equal to alpha minus beta, and delta will be alpha plus beta. Let. And now once we have that, we have to figure out what alpha and beta are going to be. So if you add the two together, gamma plus delta is equal to alpha minus beta plus alpha plus beta, which is 2 alpha. Then we have delta minus gamma is alpha plus beta minus, and it's important to put parentheses, right, you guys? That's algebra. You got to remember, when you subtract something, you got to subtract the whole thing. So put the parentheses in. Then distribute your minus signs. Alpha plus beta minus alpha plus beta.
Wait. Okay, I figured get ready to do that.
If I have 7 minus 5 equals 2, minus of 7 minus 5 is minus 7 plus 5, which is minus 2. Distribute the minus in, flipping the signs of each one. Okay? If you didn't flip this sign, you wouldn't get minus 2. Oops. Yes, you have to get minus 2, because 7 minus 5 is 2. Its negative is minus 2. Okay? All right, so this adds up to 2 beta. So that tells me alpha is, Rachel? Gamma plus delta divided by 2. And beta is? Say again? Delta minus gamma. Okay, so now we can rewrite this entire identity, but use the new letters gamma and delta. And so, since this side is over here, I'm going to start with that side. Cosine of gamma minus cosine of delta. That's how I define gamma and delta. Equals 2 sine of alpha. Alpha is gamma plus delta over 2. Sine of beta, and beta is delta minus gamma over 2. Did we get to our identity? Not quite. Okay? The trick is to recognize the only thing different is there's a minus sign difference out there, and this thing in the parentheses is not the same. But this and this, how are they related? One's the negative of the other. Right? So, delta minus gamma over 2 is minus gamma minus delta over 2. Again, that's distributing this minus sign on each piece. Okay? And so we can put in there this into there. And now sine of minus an angle is minus the sine of that angle. So that minus pulls out to there. Is that clear? Why that finishes up that way? I could just as well have written this down as the identity we're trying to derive. Okay? Instead of this one, that's the one I asked you to derive. So there's one little bit of a minus sign step there. Rachel, did that help? Okay. You were helping her figure it out too? That's fine. Okay. Okay, so that's one. There are 3 more of these, and if you were confused on this one, I suggest you try another one and just get them all straight. Any other questions on homework? And you can still turn it in next time if you feel like it. However, I'm giving out answers. The final one of these trig identity or trig review pages I'm giving out now, which has a proof of all the identities that we've done. The only ones that are missing from there are the law of sines and law of cosines. They're not on there.
Take a page of mine.
Here you are, Mark. And take one, pass them down.
Today is Monday. 4 for me. Monday's the thing with the answers, so you're all Friday's
Okay. Last time I talked about polar coordinates. Now tell me something. Did they pass it around behind you that you should have been him over there who did it?
No, there was only 3 slides.
I only passed 6. We should have been 7. Every that has a proof of all the identities I've done, except the law of sine and the law of cosine. All right, last time I talked about polar coordinates, and it's simply a different way of representing the various points in the plane by giving their distance from the origin and their angle. The angle is sometimes called the phase or the argument of the point. Okay, and we saw phase angles in trig functions, the shifting of trig functions. We saw the word phase shift. Okay, now I want to talk about algebra and solving quadratic equations. The quadratic formula, which is where you first see complex numbers. And most of you who have had Algebra 1, a good bit of this will be review. And for you, those of you who have not had Algebra 1, unfortunately it's going to go fast. So we'll try to find a compromise between them. I don't want to spend too much time, but I want to justify complex numbers and introduce complex numbers for those who haven't done much. Have you two seen complex numbers? What do you know about them?
I know, Mark told me something about a combination of 2 types of numbers.
It's a combination of real and unreal numbers.
Yes. What's an unreal number?
It's a number that is impossible.
Impossible. You can't wrap it around 2.
Okay.
Like,
So what is the square root of
1?
4 is plus or minus 2,
Yeah.
but what's the square root of minus 4?
Physics. Doesn't work.
You can't, all throughout
Camera wasn't pointing this way.
school, until you get to algebra, they keep telling you you can't take the square root of a negative number.
What?
And now you can, because you'll be able to use complex numbers to do it. Okay.
But just by itself, like,
Where does it arise? We would like to solve an equation such as ax squared plus bx plus c equals 0. And we're going to start with various special cases. Let's look at x squared minus 4. And we want to know what x's satisfy that equation.
X equals 2.
And
Negative 2.
negative 2.
Yeah.
Minus 2 squared is 4. Subtract 4.
Yeah.
Okay? How do you do that? Well, one way is to take x squared equal to 4 by adding 4 to both sides. And then you take the square root of both sides and get x is equal to the square root of 4, which means the positive 2. That radical sign always means the positive root, and so you have to put a plus or minus when you're taking the square root to say it could be either one. Okay? And so that is plus or minus 2. Okay? Okay, there's another way of solving that, and that's factoring it. You can write that as x minus 2 times x plus 2 equals 0.
Wait, how do you do that?
Okay, let's do it the other way around. X minus 3 times x plus 3 equals distributive rule. First you take this and multiply the x. Then you take this and then multiply the 3. So we have x minus 3 times x plus x minus 3 times 3.
Wait, hold on.
Okay, you got to get used to the distributive rule. And now this works, keep going. The x multiplies each of those. X squared minus 3x plus 3x minus 9. And the 3 x's in the middle cancel off.
Hold on.
Are you watching?
I'm trying to figure this out.
X squared minus 9. And so if I have x squared minus 9, I can go backwards and factor it, write it that way. Same thing goes here. X squared minus 4 is going to be this. In general, if I have A plus B times C plus D, it's going to be A plus B times C, A plus B times D, and then distributing the others, you get first AC, outers AD, inners BC, and last BD. That's called the FOIL method. First, the product of the first. Outers, the product of the outers. Inners, the product of the inners. Last, the product of the last. That's the FOIL method for multiplying them together. Okay? And so here we have the product of the first, the product of the outers, the product of the inners, and the product of the last. Since they're added together, it doesn't matter which order you write them down. Okay? And what's called factoring is doing it backwards. You start with the final formula and you want to go back to get this. And that's going to be a major topic in Algebra 1, am I correct? Yes. It takes a lot of time they spend on figuring out when an expression like this can be factored. And the easy ones to factor are the ones where there's a no middle term. Okay? And the hard ones to factor, the ones where there is a middle term. And so I'm not going to spend a huge amount of time doing this. What I'm going to do instead is just do some examples. So there was x minus 4, and I did it by factoring. If the product of two numbers is 0, one of those two numbers must be 0. X minus 2 equals 0, or x plus 2 equals 0. So x equals 2, or x equals minus 2. The back row is talking an awful lot, and it's hard for people to hear. Okay? So there we get the two solutions out of factoring. Okay? Let's look at another one and use factoring. And I'm not going to do time figuring out how it's factored. X squared minus 5x plus 6 equals 0. I tell you, I know how to factor that. I put an x in each of those, and I need two numbers which multiply to 6. So I put a 2 and a 3, and minus signs makes it work out. You got the product of the first, which is the x squared, the product of the last, which is the 6, the products of the inners, which is minus 2x, the product of the outers, which is minus 3x, and they add up to minus 5x. Okay? That was fast for somebody who has never seen factoring, right? Those who've seen factoring know how to do that already. Okay? But now you have the product of two things which are 0, so x minus 2 must be 0, or x minus 3 must be 0, so x is equal to 2, or x is equal to 3, And you can check it. This one says 2 squared minus 5 times 2 plus 6 equals 4, and 6 is 10, minus 10 is 0. Checking this one. 3 squared minus 5 times 3 plus 6 is equal to 9 plus 6 minus 15, which is 0. Okay? And so these two things, 2 and 3, are the solutions. And the goal is to find the solutions of these quadratic equations. Now, the first way you try to learn how to do it is by factoring. But that turns out not to be, in general, the easiest or the way that'll get you to an answer in all situations. So the next version you learn is what is called completing the square. You remember completing the square? And everybody groans, okay? And you get through completing the square, so I'm going to show completing the square now. So, and we're going to get past it. If you have x squared minus 6x plus 5 equals 0. Okay? What you want to be able to do is write this as the square of x plus something equals 0. You want to know what p and q ought to be. Hello? So we'll square this out. First one squared plus twice their product plus the last one squared plus q equals 0. This is what we want it to be, because that's the same as this. So we have to compare this line up to that line. If you compare them, this piece here, that's the first power of x, x to the 1, needs to be the same. So comparing them, what does p have to be in order for 2p to be minus 6? You see what it has to be? What should it be? 2p has to be minus 6. What's p?
Minus 3.
Minus 3. P is minus 3. Okay? And so then p squared plus q is, p squared is 9 plus q. That part has to be the 5. So if q plus 9 is 5, what's q?
-4.
Negative 4. Q is negative 4. And so this equation is the same as x minus 3 squared plus a negative 4, which is minus 4 equals 0. That's called completing the square. You take this, you figure out how to take the x squared and the x piece and combine them to make a perfect square. That modifies the constant, and you write it down. Okay? You can check it. Multiply it out. X squared minus 6x plus 9 minus 4 equals 0, and this is the same as that. Okay? Any questions about that? All right. So you complete the square. Now that you have the square completed, we can go to this method of solving it. And so we take the 4 to the other side and say x squared minus 3 squared is equal to 4. We get rid of the square root. I apologize, no square on there. Square there. X minus 3 equals plus or minus 2. So that's two cases. X minus 3 is 2, or x minus 3 is minus 2. I add 3 to both sides and get x equals 5, or x is equal to 3 minus is 1. Okay? So there was the factoring way of solving it, and there is the completing the square way of solving it. And factoring is nice when it works. Looking at this, I didn't see how to factor it originally, but now that I know the answer, I can see how to factor it. It factors as, I put an x there because I need an x squared. I need a 5. I need two things here which will multiply by 5, and they are 5 and 1. But I need minus signs on both of them to get a -6. So there it is factored, and that says x minus 5 is 0, or x minus 1 is 0, so x is 5 or x is 1. And that works great if you can factor it. But if you can't factor it, the completing the square way will get you to an answer. Yes, Ben?
Isn't it potentially easier if you can't factor it, just go straight to the quadratic
Hold on.
equation?
Say it again.
Isn't it potentially simpler if you can't factor it and just go straight to the quadratic equation?
Sure, I'm deriving the quadratic equation now. Okay? That's the goal of what I'm talking about, is to get the quadratic equation. In which case, you don't bother with completing the square. You use completing the square to derive the quadratic equation. Okay? All right, let's look at another one now. I'm going to change these numbers and make them uglier. X squared minus 6x plus 2. Okay, so I complete the square. First of all, this is going to have an x minus 3. Where did I get the minus 3? I took half of that. Right? And I write out what that square is. X squared minus 6x plus 9. And I want a plus 2. So I better go minus 7 equals 0. Because this is that. If I subtract 7, I get the 2. Is that clear? Okay. And so now I can continue. Take the 7 to the other side. X minus 3 squared, squared, equals 7. Take the square root. X minus 3 equals plus or minus the square root of 7. And so x is equal to 3 plus the square root of 7, or x equals 3 minus the square root of 7. Okay? It's a little uglier because you've got these ugly square roots in there. And that tells me I can't factor this using integers. I have to factor it using square roots in somewhere in there. It does factor. I'll write it out in its factored form. X minus equals 0. What are the two things that I have to put in there? They are 3 plus the square root of 7 and 3 minus the square root of 7. And if you multiply that out carefully, you will get back to this. But that's absolutely ugly. And you don't want to do it by factoring. Right? So completing the square gets you to an answer. Now I want to do it in terms of general letters of the alphabet. So this is what...
Where'd you get 7?
Where did I get 7? That's fine. What is this? This is x squared minus 6x plus 9.
Wait.
First one squared, last one squared, twice their product for the middle. And now if I subtract 7 from 9, I'll have the 2. So I have to write down whatever number is there to put there to make the constant here become what I need.
Get it.
Okay? All right. Now I'm going to do it in general. Almost in general. First, let's do x squared plus bx plus c equals 0. Okay? So I have to complete the square. So it's going to be x plus something squared plus something equals 0. And we got to figure out what to put there and then. The thing to do is put in half of that number, b over 2. And I want this, whatever's going to be here, a question mark, the constants have to add up to c. So I work it out. X squared plus bx plus b squared over 2 plus question mark equals 0. So b squared over, that's it over 4, sorry, not a 2. Do you see where I made my mistake?
You didn't square the denominator.
I have to square the whole thing, b over 2. And so I square the b and I square the 2. Okay? And now, so this here has to be c. So, c equals b squared over 4 plus question mark. C minus b squared over 4 is question mark. Any questions about that? So that's what I have to put in here. C minus b squared over 4. And that makes sense because when you square this out, you're going to get a b squared over 4, which will cancel off and leave you with the c that you need. All right? So there it is with the square completed. And now I have to do the same thing I did over here. I have to go x plus b over 2 squared equals. Taking this to the other side flips the sign. B squared over 4 minus c. Then what do I do to both sides?
Find the square root.
Take the square root. X plus b over 2 equals the square root of b squared over 4 minus c. And what do I need out front? Plus or minus. Okay? And then take this over to the other side. X is minus b over 2 plus or minus the square root of b squared over 4 minus c. We are almost there, right, Ben?
Yeah.
Almost to what you wanted. Okay. Okay. The problem with this is the thing inside the square root might be negative.
Yeah.
If b squared over 4 is less than c, you get a negative number, and, quote, you can't solve the equations. All that says is there's no real solutions to the equation. Okay? There are what are called complex solutions, or imaginary solutions. And so, for example, if b is 0, that goes away and that goes away, and if c is positive, you've got a negative number inside. Okay? And so you wouldn't be able to solve it. So this is almost the final formula. One more step is to put a number out front of that one. So let me do that one more time through in its full glory and get the final formula. Ax squared plus bx plus c equals 0. First thing I do is divide through by a. X squared plus b over a x plus c over a equals 0. I complete the square. X plus b over 2a all squared plus something equals 0. So what do I have to get in here for the something? When I square this, I've got to cancel it off that piece. So c minus b squared over 4a squared. So when I square this out, I get x squared, twice their product, which is that. This one squared is b squared over 4a squared, which cancels with that, leaving c. Whoops, c over a.
Water.
And, huh?
And drink water. Can you go get a drink of water?
Oh, sure. X plus b over 2a is equal to plus or minus the square root of b squared over 4a squared minus c over a. And I take this piece over to the other side. X is equal to minus b over 2a plus or minus the square root of b squared over 4a squared minus c over a. And there is a final formula, but it's not the way people remember it. Okay? And people remember it by putting it all over a common denominator. So first we start with the stuff inside. To get them to have the same denominator, you got to multiply here by top and bottom by a 4a. 4a, 4a. And then you write the quotient as a single thing. X is minus b over 2a plus or minus the square root. In the bottom I have a 4a squared and b squared minus 4ac up top. The square root of a quotient is the square root of the top over the square root of the bottom. So it is minus b over 2a plus or minus, oops, now it's a quotient, the square root of b squared minus 4ac over 2a. The square root of 4a squared is 2a, and the whole thing goes over a single denominator of 2a minus b plus or minus the square root of b squared minus 4ac. How many of you have memorized that? Everybody who's done algebra has memorized that formula. Okay? Minus b plus or minus square root of b squared minus 4ac all over 2a. Okay? And that immediately allows you to write down the solutions to this equation. The quantity in the square root is called the discriminant. Let me write that down. D-I-S-C-R-I-M-I-N-A-N-T. D equals b squared minus 4ac. That's the discriminant for the equation, because it discriminates between the different kinds of solutions. If b squared minus 4ac is positive, you get two real solutions. If this number is positive, then you have minus b plus or minus a real number. Square root of a real number is a real number. All over 2a, which is real, you get two real solutions. If b squared minus 4ac is equal to 0, you get one real solution. Because if this is 0, the plus or minus square root goes away and there's only one solution. Okay? It's called a double solution, because it sort of occurs twice. Okay? And if b squared minus 4ac is negative, there are no real solutions. However, we choose to give a name to both of those solutions by using complex numbers. And so that forces us sort of, in order to be able to have solutions, to introduce additional numbers, which are called imaginary and complex. So we define the square root of minus 1 is called I. Okay? Minus the square root of minus 1 is minus I.
That makes sense.
Good, that makes sense. Okay? Just like with square roots of real numbers, the radical symbol usually means the positive root. Here, by definition, it means I. If you want to have the opposite square root, you got to explicitly put in the minus sign. Okay? Yes?
Well, if it's like negative, the square root of negative 2.
So the square root, let's do an easier one first. The square root of negative 4 is the square root of minus 1 times the square root of 4, which is I times 2, and no plus or minus. This means the I, this means the 2. If you want to get minus 2I, which is also another square root of minus 4, then you have to explicitly put on the minus
You
sign.
lost me.
How is it I2?
I
Because
times
square root of 4 is 2.
The square root of 4 is 2, the square root of minus 1 is I. And it's, so people usually write it as 2 times I, but they're the same thing.
Yeah.
Just like 3 times 4 is the same as 4 times 3.
Yep.
Okay?
So it's-
And so these i's just allow you to say that there's a negative number whose square root we're dealing with. You pull off the minus 1 factor, write that as the I, the square root is I, and then you do square root of the rest of it as normal. Square root of minus 2 is square root of 2 times I. That was the question you asked a second ago. Okay? The minus 1 factor, its square root is I, and the 2 factor is just the square root of 2. Any questions? Okay. And the one important rule to remember is I squared is minus 1. So all of you get out some paper and distribute this. 2 plus 3I is equal, not equal to, times, no, let's do first plus. 5 plus 7i. What does that add up to? These are called the real parts. These are called the imaginary parts. Add the real parts. What do you get when you add the real parts? 7. 3i and 7i. What do you get when you add those? 10i.
Wait, hold on.
Okay, here are the apples, here are the oranges. And as they say, you can't add apples and oranges. So when you add the apples, you still get apples, and when you add the oranges, you still get oranges. So if I have 2 apples plus 3 oranges, 5 apples and 7 oranges, altogether I have 7 apples and 10
So
oranges.
it's negative 7.
I just carry their own thing.
Isn't it square root of negative 17?
Where's the square roots? No, I didn't tell you to do any square roots. I just told you to add these two things.
So it's 17i?
No, 7 plus 10i. It's a real number 7 and 10 times this imaginary number I.
Okay.
Okay? And there's no way to combine them any further. They are two separate things. They don't mix together. Okay? Here, let me give you another one. 4 plus 2i minus 3 minus 5i equals. Okay, what does it add up to? What's the real part add up to?
7.
4 minus 3.
Oh, wait, minus 3. Okay. 1 plus.
Remember to distribute this minus.
Right. 1 plus 7i.
Correct. Everybody got that? Okay. Now, remember the distributive formula. Let me write it over here again. FOIL. Hold on. FOIL. A plus B times C plus D is equal to, first, AC. Outers, AD. Inners, BC. Left, BD. Okay, don't forget that. Now I'm going to ask you to multiply two numbers. 2 plus 3i times 4 minus 2i. Multiply it together. Everybody, you better get your paper out. Addition is easy. Multiplication, you got to start working.
Oh, goodness. Okay, I need to work this out. No one answer.
Raise your hand when you have an answer. Okay, I'm waiting until we get more hands up. Okay, you put your hands down if you've already raised.
Wait.
I squared is negative 1. No, that's a positive.
When you get an I squared, you can replace it by -1.
14 plus.
Minus.
Oh, wait.
Don't I had 12.
Okay, I see your hands.
I squared is -1. Look, right there. I think I have it. Actually, I have it.
Yes.
I do it all. Times I.
You just write the number times I. If there are two real numbers multiplying each other, you multiply the real numbers together and leave the I sitting there. Question? Be patient. Did you get it, Mark?
What?
Did you multiply?
Just trying to figure it out.
All right. What's the product of these two?
8.
Write it down.
I wrote it down.
What's the product of the outers? What's the product of these two?
That's
2 times 3.
What's 2 times -2? -4 times the I. You have -4I.
No.
that's a call.
And the inners. Mark, what's the product of the inners?
12i.
Okay, and what's the product of the less? 3 and -2 multiplied together.
-6i.
And I times I is I squared. Right?
-6i squared.
-6I squared, right. After you write that, at the very end, after you've got an I squared, you replace the I squared by -1.
I did a different way, and I don't think I got the same answer.
Like
Okay,
this.
well, redo it and make sure. Inners, less, which will be a 3 and a -2, which is a -6, right? Where's the 6? Oh, there it is, that's a 6, not a parenthesis. Times a parentheses to say it's times -1. 6,
Means that b negative.
6 times the quantity.
But then that.
Yes, you already had a minus sign, so it becomes a plus.
So when.
All right, how many people have gotten it?
Wait, no. I got it.
Okay, I'm going to work it out now. First is 8. Outers is -4I. Inners is 12I. Less is -6I squared. The -6I squared becomes a +6. And so altogether, it is 8 and 6 is 14 plus 8I. How many of you got that?
I got it. I can't look.
Mark. Cool. Okay, so that's how you do it. Now here's another one for you to do. Oh, by the way, when you have a complex number, A plus IB or A plus BI, they are exactly the same thing. The real part of A plus IB is A, and the imaginary part of A plus IB is B. Not IB, just B. Okay? They are called the real and imaginary parts of that complex number. All right, so now here's another one for you to compute. 3 minus 4I times 3 plus 4I. Everybody compute that one. Yes, Andy? You're done. That was pretty quick. Okay. Hmm? Yes, just sit. Be patient.
No, it's all green rice.
Product of the first, product of the inners, product of the outers, product of the left.
Benjamin, yeah?
You didn't even know which ball to use. Sorry.
You got it? You got it?
I think I have it. Yes. Congratulations.
Keep working.
I'm done.
What'd you get?
We got this.
Simplify. What happens to those two in the middle?
Found it.
You got it? Okay, so what'd you get? 25. Everybody get 25?
Yes.
Yes. Okay, so this is equal to 25. What is the imaginary part of this product? Come on, guys, what's the imaginary part of this product?
No, it's 16i squared is negative 16i squared is negative 1. So you have negative 16. And then you add that.
That's how you got to this answer. Look at the answer. What is the imaginary part?
There is none.
So what is it called?
It's a real number.
What's the imaginary part of that?
0.
0. Not none. There isn't any. If there is one, it's 0.
0.
Okay? And what's the real part of this product?
25.
25. Okay. Now, anytime I have a complex number z, which is x plus iy, I define z bar as x minus iy, and that's called the conjugate of z. So here is a complex number, here is its conjugate. You flip the sign of the complex number. Julian, did you understand me? What did I say? You have no idea. Okay. Anytime you have a complex number, you flip the sign of the complex part, the imaginary part, and that is called the conjugate of the original number. So this is the complex conjugate of that number.
What do you use that for?
What do you use it for? When you multiply them together, you always get a real number. Let's do that in general. X plus iy times x minus iy. The product of the real parts is x squared. The inners is plus iyx. The outers is minus ixy. The last is minus I squared y squared. And these cancel. The I squared becomes a minus 1, so minus I squared is plus 1. It becomes x squared plus y squared. Okay? So anytime you have a number, a complex number, if you multiply by the conjugate, you get a real number, no, 0 imaginary part, okay? And the real part is the sum of the squares of the real part of x and the imaginary part, I'm sorry, of z, and the imaginary part of z. Okay? Now, in arithmetic, I'm going to ask you two really stupid, simple questions. Okay? What is the negative of 2?
Negative 2.
What is the negative of 2?
Negative 2.
Okay, that was a toughie. Okay.
Yeah.
What is the reciprocal of 2?
-1/2.
Both of them could be called opposites.
Yeah.
or inverses if you felt like it, okay? But to be specific, negative is used for the operation of addition, reciprocal is used for the operation of multiplication, okay? All right, so what is so if I have
Yes.
2, let's use 3 plus 4i. What is its negative?
Negative 3 minus 4i.
No, -3.
Okay? What is its reciprocal?
1 over 3 plus 4i.
1 over 3 plus 4i. But I want to write that as a plus bi. What are a and b? What are the real and imaginary parts of this?
1/3 plus 1/4.
No.
No?
No more than 1 over 3 plus 4 is 1 over 3 plus 1 over 4. You know that's nuts. Okay? That's bad arithmetic.
Bad.
Bad.
No more.
So you can't do that this is 1/3 plus